going to take up from multiple sources. So it can be a cloud, it can be a flat file, or it can be a relational database management system. And it is going to get from multiple sources. So this was the first. When we are going to so weight, it is going to be measured in LBS in Western countries, and for Indian countries we will measure. Now we need to have some so before we are going to make the data integration, and that it has become a lot of challenge. So that is the reason why redundancy, or that is the reason why which we are well information. So we talked about this topic. The next comes we are discussing was the chi-square. This chi-square method, what it focuses that it will look a correlation between two attributes. Obviously, I have an attribute 1 attribute. It will find the relationship. So the intention was to that will be so if we are going to talk about height and weight, if we are talking about, and that was big, now we need to correlate between height and weight. So thereby we will be getting the body mass index. So there is a strong relationship between the two attributes that it is going to be known. So how means we are going to make the correlation analysis. In this correlation analysis, going to use the value called as x square, where we are going to compute the difference between the observed and expected whole square divided by the expected, and then we are going to make a summation operation. So we get a sigma operation right from all the attributes of observed minus the expected. So we will be computing all the elements. So here is an example of calculating the chi-square method. Now you can see here there are 3 categories: glaciers, notches, and some like science friction. And now you can see 300, it is going to be the sum of the first 2 columns. It is going to be the sum of the first 2 columns. Then you can see 360 and 840. So it is going to get 1200. This is the sum of the students who are not playing any chess. Then we will 90 plus 360, we will be getting 450 here. Similarly, we will make a vertical, we will make a horizontal sum here, 10, so we'll sum as a 150, and this we are going to write here. So here is an example to find the association between the two attributes. So what we can say here was like science friction. So it says playing chess, not playing chess, not liking scientific fiction, like scientific fiction. Now, if this is the model what we are going to look, then let us calculate the. So we will calculate the correlation with this formula, that is observed minus x. So there is some network issue today. It is totally disturbing us. Now we are going to have this chi-square method. So the formula what we mentioned was observed minus expected whole square. So we have 250, that is what we are going to say, the two categories. So 250, and out of 250, 90 students are going to opt for the playing chess. So one, we are going to put this value 990 here divided by 90. So how did you make it? Means observed minus expected divided by expected whole square. So at this case, we were mentioning observed minus minus So by expect. So observed was 250 and expected was 90. Observed was 50 and expected was 210. Observed was 1000 and expected was 840. So in this way we are going to interpret the things. So we will look with 250 minus 90 by 90. Similarly, we are calculating this with 50 and 210 divided by 210. Then we will take 200 and 360 divided by this much. And similarly, the fourth one, 1000 divided by 840 minus 840 whole square. So now you can see 507.93. So what this is going to give an interpretation for chi-square method was, so people who like scientific friction and who like chess, they are totally correlated. So that is the reason why we are going to get this value as 507.93. The second way of looking the correlated analysis was we are going to use the second way, that is what we call it as Pearson coefficients. In this Pearson coefficient, what we are going to look was we will say R here of A comma B, where it is a summation between 1 to n, and we say AI minus A complement, we call it as mean value. BI minus B, we call again as a mean. And sigma, we are going to call it as a standard deviation. So n, we are going to call here as number of tuples in that relation, number of tuples in sense number of rows here. So we can look at A and sigma A and sigma B, they are going to be the standard deviation of the values cross product. Fine. Now what is the end outcome and what we are going to look? So the end outcome was if these two are A and this and it is going to be a stronger item. If it is less than 0, if it is less than 0, going negatively interpreted. So if it is 0, then what we are going to say, it is an independent value. So if the marks is greater than 90, I will give O grade. If the marks is between 80 to 90, we will give A plus grade. If the mark is between 70 to 80, we are going to give A grade. In the same way, when a Pearson coefficient is going to be applied between two attributes A and B, and we want to justify which value is correlated with other value, whether it is high, whether it is low, or whether it is equals to, then the same such of segment is going to be given. That is A greater than 0, it is positively correlated, and definitely our correlation answer will get a good impact if there is a positive relation. Then you can see the relationship between the relationship between the two attributes via the scatter plots. So you can see the attributes are going to be taken up values. So this is between -1 to 0.0, 0.40. Then in this way, and finally to 1. So this is +1, this is -1. So +1, +1, the entire correlated values are going to happen. If it is greater than 1 and towards 1, it is positively correlated. It is going to be correlated. If it is equals, we are going to call it as an independent. and if it is a negative, then it is not correlated. So we are expecting the values at this range to 1. So we will look at this scatter. The next thing what we are going to check was we establish a relationship between multiple objects. We are going to establish a linear relationship between multiple aspects. So the third technique what we are going to do was B. So we compute the mean value of A, then we will find the standard deviation. Similarly, we standard deviation, we start correlation. How we are going to do correlation? Again, we are going to expect the speed. That is, we take R value between A comma B and then we move further. We have taken only about
Sir, you are in mute, sir.
So we are going to compute this with covariance here. So in covariance, what we are going to have this is 30 here. So 30. So 10, 20, 30, 10, 20, 30, we are going to have this mean value. So obviously, we compute mean value as 30 here. So A minus A complement and B minus B complement we are going to have. So this is represented as A complement and another 30 it is represented as B complement, and thereby we are going to compute coefficient. So in this correlation coefficient we are going to have డిస్కనెక్ట్ అయిపోతుంది సార్. So from my end, a lot of network issues are there. So I'm sorry for the interrupts. So now let us look with a new word called as data reduction. So when we are talking about data reduction, the main intent was that we have large volumes of data, and this large volumes of data should be converted to smaller volume. So this is the intention. We call it as a data reduction. So how we are going to check, etc. was that we will obtain the data reduction techniques. So that is wavelet transformation, principal component analysis, feature subset selection, numerosity reduction, which contains regression and log linear models, histogram with clustering, classification and sampling techniques, and data cube aggregation. So these are some of the techniques which are going to be part of the reduction. So because when we say it is a data warehouse, it is going to store terabytes so which it is not feasible. So that is the reason why we have large volumes of data which is stored in data and terabits of data. So we have more rows and more columns. Now these need to be reduced so to smaller data with rows and columns. So where we call it as a data reduction strategy. So how we are looking with data reduction was the very first primitive we are going to call it as a curse of dimension. The very first primitive we are going to call it as curse of dimension. So when the dimensionality is going to increase, data becomes very sparse. So in order to make some analysis, etc., we can't interpret the things, the dimensionality. So that is the reason why curse of dimension is going to affect the content. So the only solution was we need to go with dimension reduction. So multiple attributes are there. If there are a lot of columns, if there are a lot of attributes, we can't do much analytics over that content. So that has to be reducted. So the possibility was that we need to pick up the combination of subspaces. The possibility was that we need to pick up the combination of subspaces. So as part of dimensional reduction, so we need to use the curse of dimensionality, that is large database is there. We are working with partial data, so we need to work with subsets. All the attributes are not needed for the relation, only few attributes are needed, only those items we have to take up. How we are going to take up means we are going to eliminate the irrelevant features. So whatever features I need, only those features I am taking, and remaining features I am not going to consider. So we call it as a elimination of irrelevant features. Next thing we will say reduce the noise. So unwanted data, what we are going to get, we say it is a noise here. So what is the advantage of taking such data means that is reducing of time and reducing of the space will definitely help the analytics with a good way, and followed by the visualization of the content will also be very good if there is a limited scope of data and it should be interpreted well. And the third thing of dimension reduction, it is going up with the techniques called as wavelet transformation, where we will use both digital content and analog content. We will call it as a wavelet transformation. And similarly, we have principal component analysis, which is the technique where we will reduce the dimensions using eigenvalues and eigenvectors, eigenvectors and orthogonality. So we will represent the data in a 3D space, and then so again there is a network issue. So how we are going to do principal component analysis, etc. was we will start with the wavelet form. Here you can see two sine waves. Sine waves, they are moving it between -1 to +1. They are moving between -1 to +1. So -1 as a lower bound and +1 as an upper bound. And then first of all we are going to use a wavelet transformation, and then we reduce the size. So when we are going to reduce the size, we will have this option where the noise is going to be eliminated, and thereby the final values are available. So this is without noise and dimensions are reduced. So the first item. Second item, what we can see here was the wavelet transformation. So when we are talking about the wavelet transformation, it is going to decompose the signal into different frequency subbands. So even your photograph was there and you will be having a blur, you will be having monochrome. So different photographs can be stated with different filters. So whenever you are going to apply a filter to that, then the photograph is going to be converted accordingly, and there we are going to compute the resolution. There we are going to compute the resolution with the pixel. So if the pixel rate is high, obviously the photograph looks nice. If the pixel rate is very low and pixels are very big, then obviously there are chances that the photograph will be low to resolutions. So you don't get good impact over that content. So that is where the resolutions are going to play a prominent factor. And mostly wavelet transformation, it is going to compress the image files, so etc. So we have a lot of filters when we look with the image files. So in image files, etc., we take up the wavelet transformation. So wavelet transformation we are going to call here as discrete wavelet transformations, where we will convert this digital to an analog wave. So when we are going to say it is a digital, it is between 0 to 1. Then if it is in a sine wave, then we are going to call this transformation as an analog transformation. So both of them, they are going to be approximated with one another. And you have learnt about the Fourier transformations, where it sees that the digital data, it is going to be converted to analog data, etc. The other word was, the second technique was the principal component analysis. In principal component analysis, we will project the larger data, that is in the two-dimensional data. We are going to project the data, or we are going to visualize the data. So we will visualize this in x-axis, and we will visualize the item in y-axis, etc. So this is how we are going to project the data, and we are going to find eigenvectors, eigen matrices and covariance, etc. We will discuss in detail what are these terms. So when we talk about principal component analysis, we need to get eigenvectors, we need to get covariance matrix, and we need to get eigenvectors to the new space. So based upon that, we are going to compute the orthogonality with the content. So based on orthogonality, we will choose items or reduce the dimensions. We will reduce the dimensions. Thereby, whatever dimensions are needed, only those items are going to be considered for the analytics. So we have lot of dimensions. From that dimension, we have reduced the data. So obviously, we are going to call that item as a subset. When we look at a subset, the most important feature was that the duplicate data, what we are going to consider, that will be eliminated. Similarly, the irrelevant data information, what are there, that irrelevant information is also going to be eliminated. So we will be getting the subset of a item. So assume that there is some student number followed by name, and then I'm going to say 10th class marks and inter marks and BTech marks and blood group and mobile. So if I am going to say this is feature 1, feature 2, feature 3, 4, 5, 6 and 7. Now the question was, I am going to ask blood group is going to ask question student number and blood group and mobile number. So now I am going to say principal component analysis. In this we will write student number, we will write blood group, mobile, 10th and inter marks and BTech marks. And to this query what are needed? So only two are going to be needed at this point of time. So total attributes, we are going to call it as 7. From this total attributes, we are going to pick only 3 items. We call here as a subset selection. We will be calling here as a subset selection item. So we will be getting the attribute subset selection at that point of time. Next comes the word called as numerosity reduction. So in numerosity reduction, the major intention was reduce the volume. So reduce the volume. Earlier we have PCAs or subset. They are going to work on dimension reduction. They are going to work on dimension reduction. Now we are going to work on numerosity reduction, and this it is going to work on CPU time. Now numerosity reduction, it is going to reduce. It is going to reduce memory space. So this is the first way to differentiate the previous technique, principal component analysis, etc. So in the earlier technique, we say that CPU time is going to be reduced. Now at this point of time, memory space is going to be reduced. So this is the first difference what we need to take. So we are going to reduce the volume. So how we are going to reduce the volume means, first of all, we will again take the parametric method. In this parametric method, we will opt the value called as a regression. So in regression, the main intention was we have dependent variables and then we are going to have independent variables. We have dependent variables and we have independent variables. So these independent variables, they are going to bring up a model to fit the data, to estimate the data. So we will identify a line and then we will estimate the error. So estimating the error, what we are going to call it as interception, and the slope is going to be found, and we will compute the error between the actual value and the expected value. Those items which are having errors greater, they are going to be eliminated. So we will expect the outliers and these outliers are going to be reduced. So this is first technique what it is going to fall in the numerosity reduction. In numerosity reduction, we are going to much focus on reduction on the memory space. So it is possible with the dependency and independency variables which is taken up from the linear regression. We call it as parameterized methods. And second technique, we are going to use non-parameterized methods where we will use histogram, we will use clustering, and we are going to use subsampling, sampling techniques, etc. So when we talk about the parametric content, the techniques what we are going to use was linear regression, and second technique we are going to call it as log linear models. So when we are going to say it is a linear technique, so you can see here data is going to be modeled with a x-axis and y-axis, and then we do have this line which it is moving between the attributes inside it, and we will compute the least square distance to identify the minimizing of error. So the actual value is posted here, the values on the line, the values off the line are also posted, and the difference between these values will be very low. So we are going to use this model least square method to fit the line. So here we are going to take only two variables at this point of time. Next, when we are dealing with multiple variables, we will be having more than one variable. If we are going to talk about more than one variable, then we are going to say we will be getting the multiple regression at this point of time. So when we say there is a multiple regression, we will use multi-dimensional feature. That means we will be using the cubic model, which it is going to be represented in three-dimensional way. And similarly, for the linear regression, the same technique we will be using, but here we will compute with log values. we will be using logarithmic values when we are going to work with log linear. But when we talk about linear models, we are going to use only the numeric data. But when we are going to use log linear model, we will be using logarithmic values. So for the numeric values, we will compute the logarithm and then we are going to pose it with x-axis and y-axis. We will assume that method here as a log linear method. So this is what we are talking, the first word called as a linear analysis, regression analysis. So in this regression analysis, we do have the word called as a response variable, which it is going to be called as a dependent variable. And the remaining elements, what we are going to assume is going to be the independent variables, or we are going to call them as a predictor variables. So we are going to draw a line, so it can be anywhere in the zone between the y-axis and x-axis. But we need to draw a line which is fitting between the data points, between the objects what we are going to take. So how we are going to derive means we are going to say between one dependent variables, another we are going to call it as an independent variables. So we will draw a line in such a way that different independent variables are pooled up together and they are going to be derived to another end, that is what we call it as a dependent variable. So we draw a best fit line, and how we are going to draw a best fit line, because we are going to compute the difference or we are going to compute the error. So this difference or error we are going to compute with the least square method. We will compute the least square method, that is x1 minus y1 whole square plus x2 minus y2 whole square. Up to n value we will compute the value and then we will be getting the minimal error at that point. So the regression analysis and log linear models, what we are going to expect was, you can see here we take two coefficients w and b. So one, it is going to have interception and slope we are going to get, and y we are going to call it as an dependent variable, and w, so we were talking about the linear regression, another one was multiple regression. So y at any point of time we call it as dependent variable, x at any point of time we are going to call it as independent variables. Then we have the coefficients, one w, another b. So w we are going to call it as interception, and b we are going to call here as a slope. So this is what the items. Now you can see the line y is equals to wx plus b. You have only one variable. We have only one variable, but at this point we are going to have multiple variables in the relation or in the model. So that is the reason why we are going to call it as a multiple regression. Now, instead of linear regression, instead of linear values, we will use logarithmic values. Instead of linear values, we will use the logarithmic values. Then it is going to become log linear models. The other approach what we are going to look was the histogram. In this histogram, data is going to be partitioned into equi-width and equi-frequency, that is equi-depth. So now you can see here green color combinations, they are going to be repeated, and you can say the bucket size is going to be equal. The other technique what we are going to show was clustering. So in this clustering, we are going to partition the data based on the similarities. Based on the similarities, we are going to partition the data. Mostly we will compute the centroid, we will compute the mean value, and thereby we are going to compute the intra-cluster and intercluster content, and that data we are going to project, which we are going to call it as a clustering. The next thing what we are going to okay, fine, we will look what we have done for today. So we talked about one dimension data integration. So in data integration, we were telling it takes up data from multiple sources. So to do this data integration, we need to have correlation. For that correlation, we use a technique called as chi-square method. And the second thing, we are going to use Pearson coefficient. Then the correlated values are put in graph, which is towards 1 is going to be taken as they are going to be highly correlated. The next thing was we can extend the topic by bringing a covariance, and the covariance, if it is greater than 0, then we can say there is lot of relationship between the expected and observed, so we call it as positive. If it is not, we call it as a negative covariance, etc. Then we started about the techniques for data reduction, because data in the data warehouse is going to be stored in terabytes of data, and which is tremendously difficult to understand the data. So we need to have subsamples, we need to have minimum samples from that content. So how we are going to take from terabytes of data to kilobytes of data means we should reduce both the column size and the row size, which it is feasible, we call that technique as dimension reductions or data reductions. That it is going to be taken up with a strategy called as dimension reduction, we call remove unwanted attributes with Wavelet transformation, with principal component analysis, feature subsection content, and the second technique was with the numerosity reduction with regression histograms and compression data. So the most important thing was dimensions are going to be very vast, that has to be reduced. So that is where we call the first concept called as curse of dimensionality. If the number of dimensionalities are more, definitely we can say that the relation will not be good. So we should avoid large dimensions, large number of features, and we should have a minimal dimensions from it. That is where we are going to come out from the dimensionality. So it is possible that we can eliminate irrelevant attributes and reduce the noise, and that is one of a technique which was proposed. So here is an example which it is taking up an image space. We have a sine wave, we have a noise. Both of them are going to be reduced with Wavelet transformation and Fourier transformation. Now you can see the data is pure. This is regarding the image processing, etc. So we have filters for the image, and after applying a filter, which is the best image for us, that we are going to select. So we call that technique as a Wavelet transformation. And after Wavelet transformation, we talked about the principal component analysis, where we are going to put the things in two-dimensional attribute. We get a good visualization on that, and which is a smaller space we are going to identify. How we are going to identify a smaller space means we compute eigenvalue, we compute eigenvector, and we compute the covariance, and thereby we understand how first attribute related with second, how second attribute related with third. In this way we are going to make a correlated value, and thereby we start up with principal component analysis. Thereby we were talking that dimensional reduction, terabits of data is there, it is occupying more space, more dimensions, that we are going to reduce, which it is going to happen with this attribute subset selection. The other was, up to now what we were talking was, it is purely related to the CPU, etc. Similarly, if we are going to work on reduction of the volume of the content, then we will be working with a techniques called as numerosity reduction. In this numerosity reduction, we will take up single variable content with independent and dependent values. We call it as a linear regression. If it is having a correlation with multiple content, then we are going to call that word as multiple regression. For the same numeric data, we are going to compute the logarithmic values, then we are going to assume it as log linear regressions. So we take two-dimensional space and we put up a dependent and independent value relationship and we analyze. That is what we get an impact for the regression models. Similarly, we use histograms to understand the data, clustering to find the similarities, to find grouping between two or more subset components. So this is what we have taken up for today. So we will end our class at this point.